Okay, hello everyone. I hope I'm audible.
Yes, you're audible and your screen is also visible.
Okay, great. Yeah, let's get going. Okay, so today's topic is evaluating RAG system performance at scale. Okay, so we're looking at, I think in the past few days, we have looked at various type of applications, some agents, some RAG, and I think we also talked somewhere about agents involving RAG as well, right? Uh, so here we talk about evaluating RAG system performance at scale. Okay. So this is part of the evals kind of analysis of AI applications, correct? So it's important to analyze AI applications from the perspective of uh, how they are performing from time to time. Okay. So if you look at traditional software applications, we really didn't have to worry too much about. Yeah, I think someone is calling me. Yeah, I think one of you can. Yeah. So in traditional software applications, there wasn't really a need to do evals and all that because whatever validation would have to be done would be done through unit test cases, correct? So when the code is being pushed from dev to prod, right? There are unit test cases which get executed, and these unit test cases cover all the possible test cases which that code should pass before it is even merged into production, right? So that is done at the DevOps layer itself, and that takes care of making sure that the application is performing as expected, right? But the reason why we need to have evals and why this makes more sense in a AI kind of an application setup is that we are using the LLMs to dynamically take decisions and dynamically give information to us based on what they understand best, right? So there are a lot of things that are moving, like moving parts in this entire RAG application, correct? And it is always possible that at any one point, correct, the things can be slightly, if something goes amiss, right? Like for example, I'll talk, a little bit about what are the moving parts and then where things can get missed, right? Like for example, we are using cosine similarity for searches, correct? What if the search is not a great fit, right? Then we are taking the top results and sending them to the LLM. Okay. So now any one of these, right? When we're sending the context, what if the LLM does not respond properly? Okay. So there are a number of things where things can get messed up, and we need to be careful about that. Okay, and that's why we need to evaluate it. Okay. Now I'll just quickly again talk about RAG, give a little bit of overaction, or overview. Okay, and I'll talk about the moving parts so that I don't know, some of you might be new. Has anyone built a RAG application in this group? Anyone built a RAG application? Anyone?
Yeah,
Okay. Okay.
yes.
Sure. Sure. Great. So, what is the vector database you've used?
I used Pinecone and ChromaDB also. To
Okay.
yeah,
Okay, okay, that's nice. So again, RAG is in a hybrid. Again, this I'm just trying to give very high level. I'll just quickly move the slides. Okay, is a hybrid AI architecture that combines information retrieval with large language models. Okay, instead of relying solely on the model's training data, so a model might have limited data. So RAG systems allow the model to get more information and help the users answer questions. Okay. So this approach also reduces hallucinations from the LLM side and keeps information up to date without retraining the entire model. So that is the advantage. So why RAG matters, right? So RAG matters basically because the language models have a knowledge cutoff and can generate plausible sounding but incorrect information. So RAG addresses this by grounding responses in actual documents. So the actual documents are provided as an enhancement to the model so that they can give more accurate information. Okay. So it's particularly valuable for enterprise applications where accuracy is critical, right? Such as customer support, um, legal research, and medical information systems, and so on and so forth, right? So RAG makes AI systems more reliable and uh, verifiable. Okay. Now, a typical system architecture consists of three parts. Okay, one is the document store. Okay, one is the retriever, right? Another one is generator. Okay, so document store is where the knowledge resides. Okay, and retriever is what searches and ranks the relevant documents, and generator is the LLM part of it. Okay. Um, so these components work together in a pipeline. So basically, you have a query, retrieve, augment, generate, and the response pipeline, right? Now, why is it important to understand these three? It's important to understand because each one of them is a very critical part, and if a mistake happens there, then the whole system gets impacted. And therefore, we need to have our evaluation system strong so that we can identify various metrics and immediately see if there is an issue somewhere. Okay. So, so how the retrieval works? Okay. So retrieval works by when the user asks a question, the system converts it again into vector embeddings, and the embeddings are compared against the other embeddings in the vector space. Okay. And the top key relevant documents are retrieved and passed on to the generator. Okay. So the quality of the retrieval directly impacts the final answer query quality. Okay. So I hope some of you are aware of these concepts. Are you aware? Are some of you aware of these concepts? I think because if you've attended last few sessions, you would have realized. Okay. Now let's move on. Again, vector embeddings. Again, this is also part of RAG, so I won't go too much of depth into this. The whatever the input PDF documents and also the user queries are all converted into embeddings and stored as embeddings in the vector space. I think one of you mentioned that you stored in Pinecone or ChromaDB, correct? So sorting and searching embeddings, again, there are various vector databases like Pinecone, VV8, and ChromaDB. So they use algorithms like HNSW, hierarchical navigable small world or FAIRS for approximate nearest neighbor search, right? So again, how do you fetch the results which are close? Some of these algorithms are used. Okay, so these databases make it return fast, even at scale, returning results in milliseconds. So chunking is again an important aspect. So you take an input PDF, which consists of a lot of pages, so let's say 200 pages, and you convert it into chunks or smaller sizes, and then convert them into vector embeddings and store them into the vector database. Okay. So some of the common strategies include fixed size chunking, sentence-based chunking, paragraph-based chunking, and semantic chunking. Okay, so various chunking strategies, but again, not really core part of evals, but yeah. So the chunking strategy significantly affects the retrieval quality. Okay. The generation phase is again an important aspect. So creating responses from the context is important. Okay, that's the last stage. And once the relevant documents are retrieved, they're inserted into a prompt and sent to the LLM. And the LLM augments the context and generates a response. Okay. So the prompt typically instructs the model to only use information from the provided documents and to admit when it doesn't know something, reducing hallucinations. So this is an important aspect because in evals, we will check. In fact, we do have various ways in which we check if the output that is coming in from the RAG system is correct or not by comparing it with the various test cases. You can say test cases. Okay. So we look at some of the strategies, how it is done. Why evaluation is critical? Okay, the need for systematic testing. Okay, so RAG systems can fail in subtle ways. Okay, for example, by retrieving wrong documents or missing key information or getting responses that don't align with sources. Okay, so one thing I wanted to kind of tell all of you is. Uh, there is suppose you have a PDF, okay, or suppose you have a PDF and that PDF has a lot of text and a lot of tables. Okay, so let us take an example of a PDF of the World Cup football. Okay, so World Cup football PDF, which consists of like say 40 pages, and it consists of a lot of text about the various football clubs around the world, and of maybe football clubs of various countries, and it also has a tabular data, two tables. One is the results of all the football World Cup matches which happened from, I don't know, 1955 till 2025. That is one table. So that basically consists of around 870 records, correct? But there'll be several columns in that table. That is one table which is there in that 40-page document. And there is another table which consists of the man of the match of each World Cup for all of those 70 or 80 matches, 70 to 80, whatever that is. Okay. Now, these are two tables which are there in the in the PDF file. And let's say these tables are spanning multiple pages in that particular PDF. Okay. So in a typical application, most people, what they will do is they will go ahead with chunking. Okay. And that's exactly why I kind of mentioned a little bit about chunking as well, right? So they go ahead with chunking and they pick one of the several chunking strategies. Okay. So like I mentioned here, there's fixed size chunking, 512 tokens, or sentence based chunking, or paragraph based chunking, or semantic chunking. So they go ahead and just say they do fixed size chunking. Mostly that's what people try to do. So moment you do fixed size chunking, what happens? A part of the table is in one chunk, a part of another table is a part of the table is in another chunk. Okay. And the third part of the table is in a third chunk. Correct. Now, when you are trying to use RAG for such an application and the user asks a question saying, can you tell me which country won the maximum number of World Cup titles from 1955 to 2025? If that is a question, then what happens is in the concept of vector embeddings, when you take this entire 40-page document and convert it into chunks using the fixed size chunking strategy, what happens is the table becomes flat, right? What do you mean by table becomes flat? That the context of the table in the second chunk and the context of the table in the third chunk is no longer valid, right? Because the second chunk does not have columns. The third chunk does not have columns. They just have rows, correct? But the first chunk has the columns and first chunk also has the data, correct? So what ends up happening, because the table has been flattened and the context is no longer there in the second and third chunks, right? What ends up happening is that um, when the user asks a query saying, tell me the country which has won the maximum number of titles, the the RAG application, because it is designed to get cosine similarity matches, it will fetch the first chunk for sure. Okay. And and it will try to get other chunks also. So let's say in the RAG application, you said that I want the top K and the K is 3. Okay. Now it so happens that the application returns the first chunk and also returns two other chunks, but they are not the second chunk and the third chunk corresponding to the table, but two other chunks in some other part of the document, which it finds as similar, right? Similar to the user's question. Now it is possible that there is some theory in that whole 40-page document or some text in that in the, let's say, 30th page or 35th page, which talks about who are the various football players and who all won various years and all that. So if it feels that that is the most similar kind of chunk for the query that the user has asked, then those two chunks and the first chunk of the table will show up, correct? Now, the point is when the LLM gets this information along the user query, which says, show me the country which won the maximum number of titles, the LLM will just give a response based on the first chunk, which is most relevant, and it is inadequate or improper, right? Simply because the LLM does not have the full context of the second chunk and the third chunk corresponding to the table, right? So if it would have had the first chunk of the table, second chunk of the table, and the third chunk of the table, then based on user's query, it can give an accurate answer because that's what LLMs are good at, correct? But now in this case, due to the way the data has been chunked, right? Now, whose problem is it? The problem is of the person who is doing the chunking, who is implementing the chunking strategy, correct? So they should be very mindful of the quality of the data and the kind of data that is going into the RAG system before they design such a system, right? Now, what ends up happening is the LLM might say only Brazil won 2 times, okay? Or maybe Brazil won 3 times, right? But the point is, let's say the correct country answer is Argentina, right? Because in the second chunk and the third chunk, Argentina won 5 times, right? But in the first chunk, Brazil is 3 times, but Argentina is only 1 time, and therefore the LLM makes a decision as Brazil based on just the first chunk, right? Now, this is a problem, right? This is a problem. And the fact that users are getting a wrong answer, nobody will be able to know, correct? Because end of the day, once the application goes into production and it is used by users, users will blindly believe whatever the application is telling, right? Because if the users start doubting every response that the LLM is sending or chatbot is sending, the RAG chatbot is sending, then there is the loss of trust in the application, and the application will have to be pulled out, right? Because at the end of the day, the RAG chatbot has to serve accurate information, right? So how do we verify this? How do we make sure that if the RAG chatbot is giving a response, it is the most accurate response possible? Okay, so that is where we have evals, right? So even if by mistake the chunking strategy is not correct, right? We are not able to provide the correct chunking strategy. Then the evals which we are trying to discuss in this session will help us catch that, right? How? Just like we are doing test cases for traditional software development, where during the CI/CD or the continuous integration and continuous deployment, the test cases are executed, and if there are any issues, the code has bugs, the test case will fail and the deployment will not happen into production, right? Just like that, here also we will have various test cases, and I will talk about a few strategies which will help us catch these kind of anomalies. Okay. Now, the issue can happen not just due to chunking itself. There are various parameters and aspects in the whole system which can make issues, which can get you issues. And we'll talk about some of these, right? The other thing is also about the dimensions, the dimensions in which how many dimensions you're storing your embeddings, what is the vector embedding model you're using, which vector database are you using, how many chunks are you sending. So there are how many chunks you're extracting and sending to LLM. There are a lot of things in this, correct? Now, if you don't have a solid evaluation strategy, then you will not be sure that your RAG chatbot or RAG application is giving you good results. So now let's move on to the next one. So why evaluation is critical? Like I said, again, I think we already did this. So without proper evaluation, you can't know if your system is production ready. Okay. So evaluation helps you compare different configurations, detect regressions, and build confidence in your system's reliability. So what are the type of RAG failures? What can go wrong? RAG systems can fail in multiple stages. Okay, retrieval failures, wrong documents retrieved, ranking failures, irrelevant documents rank too low, generation failures, basically hallucination despite good retrieval, context length issues. This is what we saw: too much little context or too much lot of context, and relevance failures. Context correct documents are irrelevant to the specific question asked. Okay. So some of these we already discussed, and therefore you need to have the evaluation correct. Okay. So whoever has answered, okay, fine. So let's look at some evaluation. What are the effective things that covers RAG evaluation? Okay, retrieval quality. Okay, answer quality, faithfulness, latency, and cost. Okay. So each dimension requires different metrics and testing approaches. So we check all of these. And what we'll do is, again, as part of this system, we will also look at Langsmith in terms of how it is. Through Langsmith, we will track how the data is being captured. Okay. So let's move on. So what are the retrieval metrics? Precision and recall. So precision and recall are important. Okay. From the perspective of the RAG system. Okay. Can someone tell me what's the difference between precision and recall? Yesterday we covered this. Can someone tell me this? Hello? Yeah. Can someone tell me precision and recall? Anyone? We covered it yesterday.
Yeah, those we can find the error. Precision, we can predict the how many are positives
Okay.
actually, and recall we predict the out of actual positives how many are predicted correctly.
Correct. Correct. That's good. That's a good answer. But of course, you think you should use the appropriate terminology. Okay. So precision measures what percentage of retrieved documents are relevant. Okay. So retrieved documents means whatever documents are retrieved are relevant to what the user is asking. Okay. Now recall measures what percentage of all relevant documents were retrieved. Okay. So let's say I have 10 relevant documents in mind. How many of those 10 relevant documents were retrieved? Okay. So if you can see the data here, for example, if your system retrieves 10 documents, okay, and 7 are relevant, okay, so the precision is 70%. Okay. So how precise is it? Okay. Now, if there are 12 relevant documents, now, 12 relevant documents in your database, which you know beforehand, the recall is 7 out of 12. Okay. So, you see that the recall is much lesser than precision, because recall is saying, I am only considering the total relevant documents of interest. I'm not seeing total documents. Okay. So, but if you see that difference again, precision is saying that it retrieves 10 documents as in the total consideration set, right? And the consideration set that is coming from the system, if 10 documents are coming and 7 are relevant out of those 10, then the precision is 70%, right? But relevant documents is going to look at your entire database, right? And you're going to say if there are 12 relevant documents, then it is 58%. Okay. So these metrics require labeled datasets with known relevant documents. This is because we need to be able to know what are the relevant documents and all these. Okay. Now, there are retrieval metrics. Okay. So like I said, over here you have retrieval quality, correct? So retrieval quality has some metrics, answer quality has some metrics. So various dimensions have various metrics. So retrieval quality has precision and recall. Okay, as two metrics. And during retrieval, we also have ranking quality metrics. Okay, so mean reciprocal rank is measures how high the first relevant document appears in the results. Okay, so MRR, if somebody asks you what is it, it says how high in the how high means how far in the rank is the first relevant document appears in the results. Okay, suppose you're getting 10 results. Out of these 10 results, the relevant document, which is the first position of that. Okay, so the first relevant document is at position 3, right? The reciprocal rank is 1 by 3. Okay. Now, normalized discounted cumulative gain, NDCG, considers both relevance and position, giving more weight to relevant documents appearing higher. So if your relevant documents appear higher in the list, what will happen? Your context to the LLM becomes much more accurate. Okay. So these metrics are crucial because users typically only look at top results. Okay. Now, answer quality metrics. Okay. So again, answer the quality of the answer which you are getting, correct? So answer quality can be measured through exact match. Okay. Does the answer match a reference answer? Exactly. So you have a reference answer, reference match, and output. You just compare both of them, right? F1 score. So what is the token overlap with reference answer? Okay. Rouge or blue, which is text similarity metrics, and semantic similarity based on embeddings. Okay. So, however, it is last point is important. These automated metrics don't fully capture answer quality and should be supplemented with human evaluation. Okay. Now, faithfulness and groundedness, so faithfulness and groundedness are important. Faithfulness measures whether the generated answer is supported by the retrieved documents. Okay. No hallucinations or made up facts. Okay. So basically, we are saying, okay, you got an answer, but is it only coming from the answer is correct, right? But is it coming from the retrieved documents or is it coming from the model's own understanding of how things are made, right? So even if the answer is correct, if the model is giving out of the context, then it is hallucination by itself. Okay, so this faithfulness measures that. So this can be evaluated by having an LLM judge whether each claim in the answer appears in the source documents. Is it really there in the source documents or not? That's what it's about. So high faithfulness is critical for enterprise applications where accuracy matters more than creativity. Okay. Now, answer relevance, the other thing is also about answer relevance measures whether the response, okay, this I think, okay, actually answers the question user is asking. Okay. So a response might be factually correct, but irrelevant to the question. Okay. For example, if asked what's the capital of France, an answer about French cuisine, while truthful, would have low relevance. Okay. This is typically measured using semantic similarity between question and answer. Now, there's another thing about context relevance. Okay, so are the retrieved documents really useful? Okay, so context relevance evaluates whether the retrieved documents contain information needed to answer the question. Okay, so even if retrieval returns documents, they might not be useful. Okay, so this metric helps identify when the retrieval system is pulling documents based on keyword matches but missing semantic relevance, right? So basically, what it's saying is I'm asking for some keywords and it is giving some sentences or documents, but they don't have semantic relevance. Okay, so yeah. Now, creating the test datasets. Okay, so good evaluation requires high quality test datasets, and this is similar to how typical software development is done. Okay, has anyone written test cases in this group ever? Any test cases while doing the software development? Anyone? Hello. Yeah. Has anyone worked on writing test cases during the software development? Anyone?
No, sir.
You have never written? Nobody has written test cases? Okay. So how are you testing your applications? How are you making sure that applications are working properly? Do you believe that whatever you write, code you write will always work? Yeah. So you should write test cases, okay? So this is for all of you. Now, good evaluation requires high quality test cases, okay? So representative questions covering your use case. So basically, what we are saying is the test cases here we are saying, okay, this is the input question, this is the expected answer. This is the input question, this is the expected answer. Your test cases will be like that, okay? Huh? Sorry. Yeah, I think somebody needs to be on mute. Yeah, there's some background noise. Okay. So basically the test cases will be like, okay, this is the input query and this is the response that I'm expecting. This is the input query, this is the response I'm expecting, right? So when we pass the input query to the system and we get a response, we compare it with the expected response and see if the response that the RAG application is giving is matching the expected response, yes or no. Okay. So that is how typically we do the testing. Okay. Now it's important to have the questions which cover all the scenarios of the use case that we are trying to accomplish. Okay. So the ground truth answers or labeled relevant documents should be there. Diverse difficulty levels and question types should be there. Edge cases and failure scenarios should be there. And basically, we start with around 50 to 100 examples and expand over time. Okay. So the test data should reflect your real user queries and not just easy use cases, right? Typically, what people do is they just write some simple use cases and leave it. But you should understand what is the test, what is the user query that the user is going to ask. That's important. Okay. Now, okay, synthetic test generation, you can also use automated dataset creation. Okay, you can use LLMs to generate test questions from your documents. Okay, so for each document or chunk, okay, prompt the LLM to generate relevant questions that the text answers. Now, do you remember, does anybody recall writing test cases? Given this context, you might have written some test cases, right? Yes or no? Anybody recall writing test cases? No? Okay. So you can use LLMs to generate test questions from your documents. So what you can do is give the entire PDF and then ask LLM to ask the questions. Okay, and we create the questions and inputs. Okay. Now for each document or chunk, prompt an LLM to generate relevant questions that the text answers. Okay. And this scales test set creation, but requires careful review. Okay, because it is possible that the test cases that have been generated through this approach may not be highly accurate. Okay, and again, you are trying to test something, but if there's hallucination or something there, that's another issue. Okay. Um, Next is human evaluation, right? The human evaluation is considered as the gold standard because human evaluation involves people reviewing system outputs and rating them on various criteria, right? So that's important. So automated quality assessment. So modern LLMs can evaluate other LLM outputs by acting as judges. So has anyone heard of LLM as a judge? Anyone heard of LLM as a judge? Yeah. So basically they are automated quality assessments. So what LLMs will do is they will act as judges for the output of other LLMs. Okay. So that is what they do. Has anyone heard of LLM as a judge? So yeah, so we are saying that if one LLM gives an output, other LLM will evaluate it. Why? Because sometimes humans can have a bias, correct? But LLMs do not have bias. Now, what we'll do is I'll show you some, some simple approach how we can, do some simple evals, right? This is very simple example, right? Suppose you have built a RAG application, okay? And now you are saying that I want to evaluate that RAG application, okay? So let's say we are reading the data from a test read underscore CSV file, okay? Test data polygram CSV itself, okay? Now, what we do is, again, this CSV file consists of all the test data, whatever we said, right? Now we said, this is an input query. This is a sample response that should be there. And that data is being loaded into a pandas data frame using pd.read underscore CSV. Okay, so test underscore df is a data frame which consists of all the test cases that we are loading in to evaluate a particular RAG application. Okay, now we define a function. Okay, so here we will define a function that will accept the query engine. The query engine is nothing but the RAG engine. Okay. The RAG engine is what will help to get the response for a given user question. Okay. Now, typically, I think most of you would generally think that RAG chatbot means it's always a UI chatbot like ChatGPT, correct? Which is not wrong, right? So it is a chat window in which users can ask questions, and these questions are going to the basically this query engine. Query underscore engine is basically the backend, which is powered by a RAG backend. Okay, so what this will do is it will answer any query that the user has asked, but it will be behind the scenes. Okay, so the front end will just be a chatbot, chat window, and the backend will be this RAG engine, right? Which is the query engine. Now we want to evaluate this query underscore engine to see if it is giving the proper responses. So what we do is we create a function called generate underscore response over here. Now what this generate underscore response will do is it will take the query engine and it will take the question which is coming in. Okay. Now, based on that question, the query underscore engine will query it and it will get a response, and that response is returned. Okay. Now, it will also return along with the context to generate the corresponding answer. Okay. Now, if you look at it again, the test questions, if you see here, test underscore questions is a list of all the questions that are there in that particular input. And what we do is we loop through each question and pass on that question to the generate underscore response function to give the responses, right? Now, the responses which we are getting it from there, we are then evaluating them and, checking if, we first put them into a dataset dictionary. Okay, if you can see here, dataset, okay, second dataset underscore dict over here, DICT, is the dictionary which is being created of all the questions, what are the responses and everything. Okay. So question of test underscore questions is going to show all the questions. Answer is getting the answer for each of them. What is the context and what is the ground truth? Okay. So why is all this required? Because we want to use an eval framework like Ragas, 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 okay, to kind of take this and then evaluate it. Okay. So now we invoke the above function on every element of the test underscore df data frame. Okay. So you can see the test underscore df data frame that is being used and build a new data frame around it. Okay. So now we use Ragas. Ragas is one of the packages which is used to generate the evals. Okay. Recall that in this case, we need a critical LLM along with an embedding model to compute similarities when needed. Okay. So we then use some imports again from LangChain. We do the regular imports of the Olama embeddings and other things. From Ragas, we import evaluate. Okay. So Ragas.metrics import. Again, we are also importing the other stuff like faithfulness, answer correctness, and context recall and context precision. So what this will do is these are all inbuilt functions or inbuilt functions which are used to kind of get these evals. So what we do is again, we import the evaluate function from the Ragas library, which is used to evaluate the performance of a RAG system by applying various metrics to measure its effectiveness. Okay. So finally, we import specific evaluation metrics from Ragas metrics, which we also discussed in the previous section or previous slide. Okay. Now moving on, what we do is we invoke the evaluation method. Okay, the evaluate method to by first defining the embedding model and Llama 3.2. Okay, which we are using as a critical LLM. So this is what we talked about, like a LLM as a judge, correct? So here what we are doing is we are calling evaluate. Now, where did we get evaluate? Evaluate we basically got from here in the previous screen where we imported evaluate from Ragas. Okay. Now, if you can see here, we are defining the four metrics that we are interested in, which is faithfulness, answer underscore correctness, context underscore recall, and context underscore precision. Recall and precision we already discussed before. Faithfulness also we discussed. Answer correctness is also something I think is also something the correctness of the answer, right, that we want. Now I think that also we discussed in one of the previous slides where we talked about faithfulness. Where is that faithfulness? Yeah, faithfulness we have talked about over here. And answer correctness also we have talked about it. Okay, where does it answer the question? Answer relevance. Okay, now, so what we are trying to do here, we are taking the metrics into the metrics array of values, and then we are calling the critic LLM. Okay, so we are seeing critic underscore LLM is an LLM which is nothing but a llama 3.2 1 billion parameters which we are running through Olama. Okay, and we are also passing the embedding model. Okay, so why is the embedding model important? Because in RAG applications, the embedding model is the main thing that goes ahead and creates the chunks, and that's why it's important for this new critic LLM to also be aware of it. Okay. So finally, what we are doing is we are passing on all of this information into the Ragas framework by calling the evaluate function to take the LLM, okay, which is critic underscore LLM, take the embeddings, which is the Olama underscore EMB, and dataset, which is Raga's eval dataset. Okay, so that is what is the one which is over here, the Ragas underscore eval underscore dataset. Okay, so this is consisting of all the test cases, which basically consists of what is the input query, what is the expected result, what is the actual result. We put all of these things into that, and we're passing that entire information to the Ragas framework. And what it will do is it will internally call again and check and validate and get the data for the respective metrics. And what are those metrics? Faithfulness, answer correctness, context recall, and context precision. And it will give the results for them. Okay. Now the evaluation underscore results object can be viewed as pandas data frame as follows. So whatever we are getting over here, which is evaluation underscore result dot scores. Okay, whatever is the evaluation underscore result dot scores, whatever we are getting out of that, we are converting that into a data frame. Okay, we are converting that into a data frame, and this data frame is stored as eval underscore scores underscore df. Okay. Now, finally, we are getting the output again for each of these parameters. We can get the output, and this is how you will get the answer correctness for each one of them. Is it correct or not correct, and what's happening? Okay. So the score of 1 indicates perfect factual alignment between the generated answer and the ground truth, both in terms of completeness and accuracy, which shows we are pretty far right now, and the system demands more inspection. Okay. So